So the essential question, how can we use the properties of logs to solve equations with variables in the exponents or inside logarithms? Okay. So we're going to be using those properties of logarithms that we talked about last time to solve equations. So first step says solve for x by taking the log of both sides. So we're using the log of both sides to simplify our exponential. So this we did work on a little bit last time. So we're going to start with that basic one, review it, give you a practice, and then we're going to go into some more complicated ones. So when you do the log of both sides, anytime you have an exponential where the variable is in the exponent, you want to do log of both sides. Now, you could do log of that base, okay? That's one way to do it. Or you could just do a log base 10. Typically, we just do log base 10s, okay? Because there are other properties that help get the exponent out of the top of that power function. So remember the power property that says you can take the exponent and put it in front. So that's what we do. X times log of 2 equals log of 14. Now we're multiplying. How do I get rid of something to get the x by itself when you're multiplying? Divide. Divide by log 2. Divide log 2. So x is equal to whatever you get when you divide that in the calculator. Log 14 divided by log 2. 807. And make sure you change that to approximately, because it's not exactly equal, it's just approximately that value, because you have to do some rounding. Okay, now, looking at an equation that has a little more to it than that first one. So I'll write some steps off to the side. First, you want to isolate the exponential part. Okay, that's the part that has the exponent, okay, and the variable. So you need to get that piece by itself. So what are we going to do first to get that piece by itself? Yeah, always do the opposite. So we'll subtract 4 from both sides. We get 3 times 2x to the x minus 6 equals 21. Divide both sides by the 3. 2 to the x minus 6 equals 7. Okay, so we got that exponential part all by itself. Now what do you think we do? Take log of both sides. Okay, so we'll do log of 2 to the x minus 6 equals log 7. Now we're going to use that power property again to bring the exponent down to the front. Make sure you keep parentheses around it because that whole piece has to stay together. So the whole exponent was x minus 6 times log 2 equals log 7. So then we used the power property. Okay, and this could change, okay, the properties that you need to use for solving. Okay, it varies from problem to problem. Here we use the power property, or it could vary. And then we're going to solve for x, now that x is out of the exponent. So it was suggested to divide both sides by log 2. So we get x minus 6 equals 2.807. And technically that would be an approximation there. And then add 6. X is approximately 8.807. Okay, now doing the logs. What's the inverse of a log? Exponential. So I have to use an exponential to try to get rid of this log. What's the base on the log? It's base 4. So I'm going to rewrite it as an exponential using the same base. So it's going to be 4 raised to the log base 4, 5x minus 1 power equals 4 to the 3rd power. Exponentiate Both sides. Okay, so you're going to exponentiate both sides. Remember that property? Yeah, if these are the same, they're inverses, that just equals 5x minus 1. That side. This is 4 to the third power. What's 4 to the third power? Solve the equation. All right, so then we solve this. Add 1. I switched colors on you, sorry. 65, divide by 5. Is that right? 13? Okay. Now, remember, it's a log. So we have to check and make sure that it works. So we exponentiated both sides. Simplify that piece. You may need to use properties. Oops. Use properties. And then solve for x. And don't forget, you have to check. Okay, you have to check. So let's go back to log. So here's my check. So you plug the 13 into this expression. Do log base 4. 5 times 13 is 65 minus 1 equals 3. Log base 4 of 64 equals 3. And so then log base 4 of 64, 4 to what power equals 64? 3 equals 3, so it works. So this is our solution. Let's look at it bigger picture. There you go.